Transmitter or electronic filters are electronic circuits which perform signal processing functions, specifically to remove unwanted frequency components from the signal to enhance wanted ones, or both. Three important why filters react under different circumstances: impulse response, recursion, and step response. Impulse response is the most straightforward way to implement a digital filter by convolving the input signal. All possible linear filters can be made in this manner. When the impulse response is used in this way, filter designers give it a special name, the filter kernel. There is also another way to make digital filters, called recursion. When a filter is implemented by convolution, each sample in the output is calculated by weighting the samples in the input and adding them together. Recursive filters are an extension of this, using previously calculated values from the output, besides points from the input. Instead of using a filter kernel, recursive filters are defined by a set of recursion coefficients. Besides of this characteristic, recursive filters are also called infinite impulse response. In comparison, filters carried out by convolution are called finite impulse response. The step response is the output when the input is a step, also called an edge, and an edge response. Since this step is the integral of the impulse, the step response is the integral of the impulse response. This provides two ways to find the step response. 1. Feed a step waveform into the filter and see what comes up. 2. Integrate the impulse response. Three types of the filter models: high-pass filter model, bandpass filter model, bandstop filter model. Which is better, the analog filters or digital filters? Let's talk about the analog filters. Analog filters are cheap, fast, and have a large dynamic range in both amplitude and frequency, while the digital filters are vastly superior in the level or performance that can be achieved.
Analog signal processing, we created filters from resistors, capacitors, inductors, and op-amps. In digital signal processing, we create filters with an analog to digital converter, a digital filter composed of registers, delay units, multipliers, and adders, and a digital to analog converter. We will discuss digital filtering operations by using the low-pass filter example that we used last lecture. First, we input the signal x sub a of t, which has high and low frequencies, into the A to D converter. X sub a of t is sampled by the periodic switch and quantizer to create the digital signal x sub n. X sub n would then be stored in computer memory as a set of bits. X sub n is then sent to the digital filter, which will produce the low-frequency discrete signal y sub n. Here's a generic example of a digital filter. The digital filter creates y sub n by applying a series of delay operations, multiply operations, and add operations. Notice how the subscripts change with every delay. This filter is expressed by a difference equation that is created by mapping the add and multiply operations to a mathematical expression. For example, we multiply x sub n minus 1 by a sub 1 and add it to our final y sub n. We will discuss difference equations in greater depth later, so this is just an introduction. When there is no feedback loop, we say that the filter is non-recursive and has finite impulse response. When there is a feedback loop, we say that the filter is recursive or has infinite impulse response.
Digital filters are used for two general purposes: the separation of signals that have been combined, and the restoration of signals that have been distorted in some way. Filters in digital camera. Polarizer. It can darken blue skies, increase contrast of partly reflecting subjects, and reduce reflections from non-metallic surfaces like gas and water. UV filter. Black and ultraviolet light which can cause bluish cast in image shot where there's a lot of UV. Graduated neutral density filters are used when the dynamic range of a scene exceeds the capabilities of the camera to record detail in both the brightness and darkness part of the scene. Neutral density filters simply absorb light of all wavelengths. Infrared filters use a filter in front of the sensor which allows light to pass but block all of the infrared. Special effect filters. The effects of most of these can actually be duplicated digitally.
Da poca picchita va bene, se tu la parla miezza americano, quando si fa l'amore sotto la luna, come da bene in capo di I love you, papà l'americano.